Hi, so this is for Chem 1, and we're going to be going over the theoretical yields. Theoretical yields and actual yields are what you need to know for these problems. And what is the theoretical yield? The theoretical yield is how much you're supposed to make if you calculate everything perfectly and if everything in the lab went perfectly. Now, in real life, in practice, when you go into the lab and do something, you're not going to make as much as what you calculate you think you should be making because there's, moisture in the water or moisture in the air, and the air conditioning might be on, so the temperature's different or something, just different little variables that you can't really control that's going to alter how much you actually make in the lab. But the theoretical yield is how much you're supposed to make if it were a perfect world. So the theoretical yield is just what you calculate that you're going to make. So that's what this question is asking. What is the theoretical yield? What do you calculate that you're supposed to make? In grams of CUS, so that's going to be this end result here, this product here, CUS, for the following reaction, given that you start with 15.5 grams of Na2S, so you're going to have 15.5 grams of this Na2S and 12.1 grams of CuSO4. So this is going to be 12.1 grams of CuSO4. Now, the first thing we're going to do is we're going to look and make sure that this formula is balanced. And if you check to make sure that there's both the same amounts of each element on the left side of the yield arrow as there is on the right side of the yield arrow, then you can see that this equation is balanced. So you only want to do this with balanced equations. Next, we're going to make our data table of molar ratios, and that's just the ratios of the moles of these molecules compared to the moles of the product. So in the reactants, the substances on the left side of the arrow, there's an invisible 1 here, so 1 Na2S, and there's an invisible 1 here, 1 CuSO4. And if you look at the end, the question is asking about the CUS, and there's 1 mole of CUS here. So the question's not really asking about the Na2SO4, so we can just ignore that. So we're going to make our data table. We're going to start with the Na2S. So 1 mole of Na2S is going to yield 1 mole of CUS. And also, if we look at our reactants, 1 mole of CuSO4, 1 mole of CuSO4 is going to yield 1 mole of CUS as well. So we're taking these two reactants separately in their relationship to the product CUS. Now this is asking for grams, so we need to figure out how many grams are in a mole of each of these substances, of the Na2S, of the CuSO4, and of the CUS, because these are the 3 substances we're working with. So the first one is Na2S. So Na, let's look at our periodic table. And Na is over here on the left. So that's 22.99. So Na is 22.99 grams per mole, but we have 2 of these Nas. We have 2 of them, so we need to take that times 2, which is 45.98 grams. Then we need to find out how many grams are in a mole of S. So let's look at our periodic table again. So here's S over here on the right. So here's S over here on the right, and that's 32.07. So 32.07 grams. So we need to add this 32.07 grams and this 45.98 grams, which will give us 78.05 grams per mole of Na2S. So we can write that down in our data table now. 1 mole of Na2S equals 78.05 grams. Now we need to do the same thing for CuSO4. So copper, Cu, let's look at our periodic table. Copper is going to be in the transition metals right here, and that is 63.55 grams per mole. So 63.55 grams. And S, if we remember from when we did the Na2S, S is 32.07 grams. And then oxygen is 16 grams, and there's 4 of them. So that's 64 grams. Now we need to add all these up, the 63.55, 32.07, and 64. And that is going to give us 159.62 grams per mole. So now we can write that in our data table. So 1 mole of CuSO4 equals 159.62 grams. Now, one more time, we need to do the product, the CuS, and find out how many grams per mole CuS has. So copper is 63.55 and sulfur 32.07. So if you add those together, that's going to give you 95.62 grams per mole. And we can write that down in our data chart. So 1 mole of CuS equals 95.62 grams. So now what we need to do is we need to do 2 separate problems. We need to do a problem for the Na2S and find out how much 15.5 grams of Na2S, how much of the CuS it's going to make. And then we need to do a second problem finding out if we have 12.1 grams of CuSO4, how much of the CuS we can make. So the first problem is going to be how many grams of CuS are we going to make with 15.5 grams of Na2S. So we start with the question mark statement, and we put down what we know, which is the 15.5 grams of Na2S. So let's write that down. And we put that over 1, and then multiply and a fraction bar. And then whatever we put on the top here of this fraction, the grams of Na2S, that's what we write on the bottom of this new fraction bar, grams of Na2S. And we look and see in our data table where is listed grams of Na2S. And that would be right here, the 78.05 grams of Na2S. So 78.05 grams of NA2S, and then whatever's on the other side of the equal sign goes on the top of the fraction. So that's 1 mole of Na2S. And then multiply and a fraction bar. And whatever we wrote on the top of this last fraction, moles of Na2S, we write on the bottom of the new fraction bar, moles of Na2S. And we look up at our data table for another place where it mentions moles of Na2S. And we already used this one, so we can't use that again. But up here in this row on the top, it has moles, 1 mole of Na2S. So we're going to write the 1 down, 1 mole of Na2S. And whatever's on the other side of the equal sign, we're going to write on the top of the fraction bar, 1 mole of CuS. And then I ran out of room, so I'm going to go down here. And then another multiplication sign and another fraction bar. Now, whatever we put on the top of the fraction that we just wrote, which is moles of CuS, we're going to put on the bottom of this new fraction, moles of CuS. And we're going to look for where another mole of CuS is mentioned in the data table. Now up here on the second row, we have moles of CuS, but that has to do with CuSO4. And we're not dealing with CuSO4 right now. We're dealing with Na2S. Remember this 15.5 grams? So we're going to look further down in our data table, and we're going to find this row down here on the bottom, 1 mole of CuS equals 95.62 grams of CuS. So that's what we're going to use. We're going to use 1 mole, we're going to put 1 mole of CuS in the bottom, and on the top of the fraction, we're going to put that 95.62 grams of CuS. And we can cross that out because we just used that. And the other two items in our data table are about CuSO4, and we're not dealing with that right now, so we don't need to use those. Now, we need to cancel out all of the units of measurements that are diagonally across from each other. So this grams of Na2S cancels out with this grams of Na2S. This mole of Na2S cancels out this mole of Na2S. And this mole of CuS cancels out this bottom mole of CuS down here, leaving us only with grams of CuS. Now, is that what the question is? Does that answer the question? Let's look back over at our question mark. And yes, we have the question is how many grams of CuS? And that's what we're left with for a unit of measurement. So we know we set this up right. So now we can just multiply. So we end up with 15.5 times 1 times 1 times 95.62 grams of CuS over 1 times 78.05 times 1 times 1. So the total amount, the total from this is, going to be 18.98923767 grams of CuS. So now that we've done that, that's how much CuS in grams is yielded from this 15.5 grams of Na2S. So now we need to do this whole thing over again, but with the CuSO4. So now we're going to do this over again with CuSO4. And the question is not going to be how many grams of CuS is made by 15.5 grams of Na2S. Instead, the question is going to be how many grams of CuS is made from 12.1 grams of CuSO4. So we start with what we know in the question mark statement. So 12.1 grams of CuSO4 over 1, and then multiply fraction bar. And whatever we wrote on the top, we have to write those units on the bottom of this next one. So grams of CuSO4. Now let's look up at our data table and find out where it says grams of CuSO4, which is right here. We have 159.62 grams of CuSO4. And whatever's on the other side of the equal sign, we put on the top side of the fraction bar. And then multiply fraction bar. Now the last fraction we wrote on the top, it says moles of CuSO4. So that's what we put down on the bottom, moles of CuSO4. And we already used this on our data table, so we can't use it again. So we're going to look at another place in our data table where it mentions moles of CuSO4, which is right up here. We have 1 mole of CuSO4, so we're going to write 1 down. And then on the top side of the fraction bar is going to be the 1 mole of CuS. So we used that. And then I ran out of room again, so I'm coming down here. So multiply and another fraction bar. Now on our last fraction, on our top of the fraction bar, it has moles of CuS. So we're going to put that on the bottom this time, moles of CuS. And we're going to look up at our data table and find out where it says moles of CuS. And that would be right here. It has 1 mole of CuS is equal to 95.62 grams of CuS. So now we can cancel out our units of measurement. So we start off with this grams of CuSO4, and this is diagonally cancels out with the grams of CuSO4 down here. And then on the top there's moles of CuSO4, which cancels out with the diagonally moles of CuSO4. And then we have moles of CuS, which cancels out with this mole of CuS down here, leaving us with grams of CuS. Well, is that what we're looking for? Yes. The question mark is question mark grams of CuS. So we know we set it up right. So now we just have to multiply across and then divide. So 12.1 times 1 times 1 times 95.62, all divided by 1 times 159.62 times 1 times 1. So that's going to give us 7.24 8477, and we're just going to round this up to 7.25. So 7.25 grams of CuS. So what we found from those two problems was that 15.5 grams of Na2S is going to yield 18.99 grams of CuS. But 12.1 grams of CuSO4 is only going to yield us 7.25 grams of CuS. So as you can see, these amounts of the Na2S and the CuSO4 are going to yield different amounts of CuS. So we have to choose the one that makes the least amount of CuS, because that's all that we can make. All we can make is the 7.25 grams of CuS, because we only have 12.1 grams of CuSO4. So the CuSO4 is going to be the limiting reactant. So that's just the reactant that has the least amount of it in there. So we can only make as much as what the limiting reactant can make. So the answer to this question is, what is the theoretical yield in grams of CUS for the following reaction, given that you start with 15.5 grams of NHUS and 12.1 grams of CuSO4? We can make 7.25 grams of CUS. Now, our next problem has to do with that problem we just did. So it says, what is the percent yield of CUS for the reaction if the actual amount produced was 3.05 grams? So we had the theoretical yield from the previous problem, which was 7.25 grams of CUS. Now the actual yield, and this is what I was talking about, once you get in the lab, you're not actually going to make 7.25 grams of CUS. You're only going to make a small amount of that. So the actual yield is, and they give that to us, is 3.05 grams of CUS. So the percent yield is just what you get when you divide the actual, what you actually make, divided by the theoretical, what you should theoretically make, just by doing the math. So that's going to be, the actual is going to be the 3.05 grams of CUS, and the theoretical is going to be the 7.25 grams of CUS, which is 0.420689655. And then we take that and we can just round to 0.42. So we just take that 0.42 and times it by 100%, and that's going to give us 42%. So we made, with that 3.05 grams of CUS, we made 42% of what theoretically we calculated that we should make, the 7.25 grams. We only made 42% of that.